All right, so get this, right? We're diving into robots today, but like not just A and Y robots. We're talking about robots that can operate offline.
Yeah, it's a really interesting development.
So they can make decisions, take action, all that without needing instructions from, the cloud.
Exactly. We're talking about moving away from purely internet-dependent machines. It's a big shift in robotics.
Towards more, what would you call it? More autonomy.
Autonomy is a great way to put it.
Okay, so there's this company, Figure AI, and they've created these humanoid robots that can function both online and offline. It's like, what, a robot brain that can switch gears depending on the situation?
That's a pretty good analogy. Figure AI actually calls it a dual system. So they use onboard processing for tasks that need like immediate action. Think grabbing an object, moving around a room.
Right, the quick stuff.
Exactly. And for that, they're using some seriously powerful GPUs. But when it comes to, say, bigger picture planning,
the stuff that requires a ton of data.
Exactly. That's when they can tap into these really powerful external servers. Brett Adcock, Figure AI CEO, he calls them mega computers.
Mega computers. Okay, I kind of like the sound of that.
It's catchy, right?
It is. So it's like having, what, a supercomputer on standby for all those really complex tasks?
You got it.
Okay, so walk me through this. Let's say, hypothetically, a Figure AI robot is given the task of, I don't know, organizing a totally chaotic warehouse. How does this whole dual system actually work in a situation like that?
Okay, so picture this. The robot is told, right, go reorganize this whole section of the warehouse, figuring out the best way to move everything, optimizing the layout, that kind of thing. That's a huge EE computational task.
Yeah. Way too much for just the robot brain.
Way too much. And that's where the mega computer comes in. So the robot would offload that initial planning stage to the external server.
So the robot's basically saying, hey, mega computer, you figure out how to tackle this mess. I'll get started on what I can handle right now.
Exactly. And while that server is, crunching numbers, coming up with a master plan, the robot's not just standing around.
Right, because it can still do stuff offline.
Exactly. It can use its onboard processing to start moving boxes, clearing pathways, maybe even some basic sorting based on, size or weight, all in real time. No need to wait for instructions for every little thing.
Wow, so we're talking next level multitasking here. It's like having a super efficient warehouse worker who also happens to be like a strategic mastermind.
It's a powerful combination.
It is. But, okay, why is this whole offline capability such a game changer? I mean, yeah, warehouses can have spotty Wi-Fi, but is that the main reason behind this technology?
It's definitely a factor, but it goes way beyond that. Think about it. You've got factories, construction sites, even hospitals, where you need robots that can function consistently no matter what.
Right. You can't have a dropped internet connection in the middle of, like, surgery or something.
Exactly.
Yeah, not good. Yeah. So Figure AI, they're betting on this hybrid approach to make their robots more, reliable?
Reliability is a huge part of it. More adaptable, too.
Adaptable. Okay. And that's especially important, it seems, when we're talking about their focus on integrating these robots into the workforce, right?
100%. Especially in those environments where, like we said, consistent performance is absolutely critical.
Yeah. Okay, so instead of, going straight for our homes, they're starting with workplaces. It's like they're saying, let's perfect this tech where it really matters, before we unleash it on our messy living rooms. But why the workforce specifically? Why not start with something a little less, I don't know, demanding?
Well, homes, they're tricky.
Yeah, what is it about homes that makes them so difficult?
They're unpredictable. You've got constantly changing layouts, unexpected obstacles, like kids running around.
Pets, you name it.
Exactly. A lot for a robot to handle,
yep.
Especially one that's, still learning. Workplaces, now those can be more structured.
So especially places like factories, warehouses.
Right, exactly. More predictable.
Which makes it easier to train the AI.
Way easier. In those environments, the algorithms, they can really learn, really adapt, because the rules are a bit clearer.
So it's like, you wouldn't throw a rookie firefighter into a raging inferno right away, right? Start them off slow, controlled environment, then you up the challenge. Makes sense. But this whole offline capability thing, this isn't just a Figure AI thing, is it?
Oh, not at all.
What about other companies? Like, you mentioned Tesla, Boston Dynamics. What are they doing in the offline robotics world?
So they're both big players, obviously, and each has their own approach.
Yeah.
Like, take Boston Dynamics' Alice robot. That thing is famous for its agility.
I've seen the videos. It's kind of mind-blowing. Jumping, running, even navigating like some seriously rough terrain.
And a lot of that comes down to its onboard processing power. They've got these amazing sensors that allow it to basically react to its environment in real time.
No internet required. Then there's Tesla, right? With their Optimus robot.
Right, and Elon Musk, he's been pretty vocal about wanting Optimus to be this like multi-purpose robot, as comfortable in a factory as it is in your kitchen.
Ambitious.
Totally. And that requires a ton of adaptability both on and offline.
So it's like we've got Figure AI focusing on the workforce, Boston Dynamics pushing the boundaries of like what robots can physically DO, and then Tesla going for this like jack-of-all-trades robot. And they're all working on this offline capability, but their visions for how these robots will actually be used, they're pretty different, aren't they?
Yeah, and that's what makes this whole field so fascinating. These strategic choices, they're going to shape the future of robotics in ways we can only, begin to imagine.
It's like we're at the starting line of some kind of like robotic Grand Prix, and each team has a different strategy for how they're going to cross that finish line. But, okay, back to Figure AI for a second. We talked about their approach, their vision, but what's the tech behind all of this? These robots are powered by some serious AI, right?
Oh, absolutely. And this is where it gets really interesting. Figure AI is using NVIDIA H100 GPUs.
Okay, so those are
the heavy hitters, the rock stars of processing power, basically.
So not your average computer chips, then. What makes them so important for Figure AI's robots?
Think of it this way. These GPUs are specifically designed for handling massive, and I mean massive, amounts of data.
And AI systems like these robots, they need that data, don't they?
Oh, they crave it. We're talking about processing real-world sensory input, vision, sound, touch, all in real time to allow for like really complex decision-making.
So it's not just about like crunching numbers, it's about making sense of the world almost the way that we do, but at a speed and scale that we can't even comprehend.
It's like giving them a crash course in understanding the world, but instead of years of experience, it's happening in a fraction of a second.
Incredible. So you're giving these robots a supercharged brain that's constantly learning, evolving.
Exactly.
But even with all of that, even with this whole hybrid approach, I mean, building robots for the real world, that's got to be a massive undertaking. What are some of the, I don't know, the biggest challenges, the things that keep Figure AI and probably any company working on this up at night? What are the hurdles they've got to overcome?
Well, one of the biggest ones, and we touched upon it earlier, is unpredictability.
Right, because even in a controlled environment, like you were saying, even in a warehouse, things happen, right?
Stuff goes wrong. All the time.
Spills, obstacles, new tasks that the robots haven't seen before. How do you even begin to prepare for that?
That's where machine learning comes in. These robots, they're not just pre-programmed with a set of tasks. They can learn from their experiences, both the good and the not so good.
Mistakes.
Right, the mistakes. So Figure AI, they've developed these algorithms that allow the robots to adapt to new situations, learn from their environment, and get better over time.
So it's not just about building a robot with like impressive hardware. It's about creating a system that can, I don't know, think on its feet, learn as it goes. Okay, so this whole idea of robots, becoming more integrated into our world, it's going to come with some anxieties, right?
Of course.
I mean, I've seen enough sci-fi movies to know that things don't always go according to plan when robots get involved.
Right. Well, it's important to approach all of this with a healthy dose of, caution and responsibility.
Okay, but really, what are we worried about? I mean, are we talking like full-on robot uprising?
I think we can safely say the robot uprising is not imminent.
Okay, good to know. Good to know. So what are the real concerns then?
Well, one of the big ones, and it comes up a lot, is jobs.
Right.
As robots get more advanced, as they can do more of the tasks that humans used to do, well, you have to think about job displacement.
It's tough to ignore that, yeah. Especially when you see how fast this tech is moving.
Absolutely. And it's a really important conversation to have as a society. How do we prepare for a future with even more automation? How do we make sure that people whose jobs are displaced, how do we make sure they have opportunities?
Right. We need to find a balance, right? Embrace the good stuff, but be ready for the changes too. But what about other concerns? Security has to be a big one, doesn't it?
It is a big one.
These robots, they're handling a ton of data.
Yeah, and especially when you're talking about, workplaces, hospitals, eventually even homes, security is paramount.
Right.
Figures AI and other companies, they know this,
Yeah.
and they're putting a lot of resources into cybersecurity.
Right.
Because you got to protect these robots from hackers, from attacks.
So it's like a constant back and forth.
It is. It's a bit of an arms race,
Yeah.
trying to stay one step ahead of the bad guys.
Makes sense. You can never let your guard down on security, especially with this kind of tech. Okay, so we talked about Figure AI, their approach, but are there other ways to solve this offline robot challenge?
There are. Figure AI is just one piece of the puzzle, right? Another really exciting area is what's called specialized offline skills.
Specialized offline skills. So these are robots that are designed to do like very specific things.
Exactly. Things that by their nature are going to be in environments where the internet is just not an option.
Okay, so like what? Give me some examples.
Think deep sea exploration.
Right. No Wi-Fi at the bottom of the ocean.
Exactly. Or, disaster relief efforts, maybe even space exploration.
Oh, wow. Space.
Yeah, these are situations where you can't just rely on a stable connection. The robots, they need a lot of autonomy. They need to be able to make those split-second decisions, take action based on what their sensors are telling them, based on what they already know.
So how do you even begin to prepare a robot for that level of like independence?
Well, it takes a lot of advanced programming, really sophisticated sensors so they can understand their surroundings. And a lot of times you're also talking about machine learning so they can adapt to those curveballs, the stuff you didn't see coming.
It's really incredible, though, when you think about it. But you also mentioned edge computing, right, earlier on. And that's like what? Giving the robots a little bit of a brain boost, letting them handle some stuff locally?
Exactly. Oh, instead of all the data going back and forth to a central server.
Which takes time, and maybe the connection's bad.
Exactly. With edge computing, you're bringing the processing power closer to the source of the data.
So it's like having, what, a little mini supercomputer right there on the robot itself.
It's getting closer to that. Yeah, it's not quite there yet, but that's the idea. More localized processing, faster decisions, more reliability, and less dependence on that, sometimes shaky internet connection.
So you're giving these robots a little taste of freedom, a little more independence to operate out in the world. It's amazing, though, when you step back and think about how far we've come and where this is all headed. We're talking warehouses, deep sea exploration. I mean, these offline robots, they have the potential to like really change things, don't they?
I think so. And what's exciting is we're just getting started. As AI gets more powerful, as we create even better algorithms, better hardware, who knows what these robots will be capable of?
It's exciting, but it's also a little, a little daunting. Like, it's hard to wrap your head around all the possibilities, good and bad.
It is. And that's why these conversations are so important. We can't just talk about the how. We have to talk about the why and the what if. What do we want the future to look like with robots in it? How do we make sure they're used for good?
Those are big questions.
They are big questions.
But clearly, Figure AI, all the companies working on this, they're thinking about these things, right?
Oh, absolutely.
Yeah.
They understand the responsibility that comes with this technology.
It's not just about what they can do. It's about what they should do.
Exactly.
Well, I think we've done a pretty thorough deep dive on offline robots today. We've covered a lot of ground.
We have the technology, the potential, the challenges, even some of the ethical stuff we have to consider. It's a lot.
It is. And it's evolving every day. So to everyone listening, thanks for joining us for this deep dive. We hope you found it, as mind-blowing as we did.
And until next time, keep exploring, keep asking those questions, and keep imagining what the future might hold.
Who knows, maybe next time we'll have an offline robot co-host. Wouldn't that be something?